Hi students, in this lecture we are going to learn beats. See what is the meaning of beats. Right, let us consider two sound sources. Consider two sound sources. Let us take S1 and S2. You can say two speakers, okay? These are nothing but two speakers. Let us say there is a person here, somewhere here, a person. A person. Now one condition is they have different frequencies. I am taking here omega 1, omega 2. Angular frequencies omega 1, omega 2 means they have different frequencies, means f1, f2. Now writing equations, because of first one, p1 equal to p naught sine omega 1 t, p2 equal to p naught sine omega 2 t. See here we are not writing plus kx or minus kx. So understand why it is. Sound coming from speaker 1 reaching the person. Sound coming from speaker 2 reaching the person. Now these two are superimposed. So when they interfere, intensity changes. It may be maximum intensity or it may be minimum intensity, which depends on the phase difference. And if you see carefully, phase difference equal to, from these two you can write phase difference equal to, let us take as a phi, or you can say delta phi, that is equal to omega 1 difference omega 2 into t. So if you focus at this point, if you focus at this point, as time passes, this value keep on changes. See carefully. For example, when t equal to 0 at point P, t equal to 0, no phase difference, right? But after some time, this phase becomes like pi. After some more time becomes 2 pi. Next becomes 3 pi. Next becomes 4 pi. At same location, phase value keep on changing. So here we are fixing the location. So location has no role. That's why we have not taken kx term, because whatever may be the location, at that fixed location, phase keep on changes with the time. When phase difference becomes 0 or 2 pi or 4 pi, 6 pi like this, intensity of a sound is maximum. That is constructive interference. Sometimes there's a phase difference equal to pi, 3 pi, 5 pi and so on. Then sound intensity will be minimum. That means for a person who is at this location, he hears now maximum sound, minimum sound with some regular time intervals. Okay, this is what we call beats. This is what we call beats. That means two sound waves of slightly different frequencies. When they superimpose, we hear sound of changing intensity. Intensity changing maximum to minimum, minimum to maximum. This is what we call beats. And here we are saying difference of frequencies must be less. Why means? Because for human beings, persistence of hearing is 1/10 of a second. That means if difference is more, we cannot hear clearly. If difference is more, we cannot hear clearly. Okay. Now see what happens when we take P1 plus P2. So P equal to P1 plus P2 that is equal to sin A plus sin B. That becomes that becomes 2 P naught sin of A plus B by 2 sin of A plus B by 2 cos of A minus B by 2 cos of A minus B, or you can say omega 1 difference omega 2 by 2 into T sin omega 1 plus omega 2 by 2 into T. Now what I am doing here, see carefully this part. In the place of pressure amplitude, it is 2 P naught cos difference of omegas by 2 into T. So this value keep on changing with the time. I am repeating. This value keep on changing with the time. Okay. So for this function, frequency is f1 minus f2 by 2. Let us do one thing. I am writing this as this is equal to p equal to some p dash sine omega 1 plus omega 2 by 2 into t. Now in this frequency of p dash, see how much? F1 difference F2, F2, F1 difference F2 by 2. That is frequency of that function p dash. Okay. Now sound is maximum whenever modulus of p dash is maximum. I am repeating. Sound is maximum whenever modulus of p dash is maximum. See carefully. This is a sine cos function. Cos function becomes 2 times 0 in one cycle and becomes once maximum and once minimum, means plus 1 minus 1 and 2 times 0. But if you focus modulus of cos, it becomes 2 times maximum, 2 times minimum. I am repeating. If you take modulus of this p dash function, okay, then this modulus of cos function becomes 2 times 0 and 2 times maximum in one cycle. Okay, that means we here maximum intensity 2 times and minimum intensity 2 times in one cycle. I am repeating. In one cycle, we here 2 times maximum, 2 times minimum. And one maximum and one minimum is called one weight. I will write here frequency of mod p dash is f1 difference f2. That is twice the frequency of p dash. P dash means cos function. Modulus of p dash, it is modulus of cos function. That's why twice. Okay. Getting the point. This is the frequency of modulus of p dash because we have to focus whenever change in pressure is maximum, we hear maximum intensity. Okay. That means frequency of modulus of p dash f1 difference f2. Let us say f1 equal to 10 H, f2 equal to 6 H. Okay, difference equal to 4. That means in one cycle, we hear 4 times maxima, 4 times minima. I am repeating. difference equal to 4. That means in one cycle, we hear 4 times maxima, 4 times minima. Okay. That means beat frequency. What is it? Beat frequency equal to 4. Beat frequency equal to 4. 4H. So one maxima and one minimum. One maximum and one minimum is called one beat. So we hear now 4 maxima and 4 minima. That's why it is a 4H. Okay. So why we have taken modulus of P dash? The reason is that whenever modulus of cos becomes maximum, we hear maximum sound. Modulus of cos. That means cos value minus 1, modulus value plus 1, right? So bit frequency equal to F1 difference F2. So I'm repeating once. We have taken different frequencies at same location. We are not changing location, but with the time, phase is changing. That means at same location, we hear maximum sound, we hear minimum sound. So this is an example for interference in time. I'm repeating. This is an example for interference in time because this is only depending on time but not position. Okay. Let us see notes once for this. Yeah. So it is an example for interference in time. So we see that amplitude of resultant wave is not a constant but varies with the time. Okay. Na? We have seen that, right? Measure amplitude depending on time. In case of a sound, varying amplitude gives rise to variations in loudness. Means loudness is more, loudness is less, which are called beats. Okay. Right now we have taken equations. Sine omega 1t, sine omega 2t, then 2p naught cos of this function, sine of this function. For this entire wave, frequency is f1 plus f2 by 2 entire wave. Coming to for this function frequency is f1 difference f2 by 2. See carefully. For this function frequency f1 difference f2 by 2. But if you take modulus value, modulus, then frequency becomes f1 plus f2, means twice of this frequency. Okay, because we want modulus of this function to decide loudness of sound, right? Okay, so frequency of amplitude is f1 difference f2. Relation is amplitude means we should take modulus value. That's why f1 difference f2. Okay, see carefully. If you ask frequency of this function, f1 difference f2 by 2, but modulus of this function, that is amplitude, because amplitude can never be negative. Okay, so modulus 1 means f1 difference f2. That is what we have taken here. And frequency of entire wave is f1 plus f2 by 2. So this is directly from that mathematics, right? Okay. See next one. So this is how the wave pattern appears. First one, delta P1 as a function of time, delta P2 as a function of time. You can see here, this is what we call, you can say one is a compression, one is rarefaction. Okay, or you can say change maximum, change here minimum. Okay, now see what happens here. This is what we call destructive interference. Destructive means compression falling on rarefaction. What is it? Compression falling on rarefaction. Then what happens? Delta P is 0. Delta P is 0. This is now minimum intensity. Now see here, compression falling on compression. Intensity is maximum. See, delta P is maximum. Delta P maximum means intensity maximum. One minimum and one maximum. This is one beat. And you can see once again here, minimum. Compression falling on rarefaction. Okay, delta P positive here, delta P here negative. Net value how much? Zero. Okay. Coming to here, delta P positive, this also positive. So total value is maximum. Delta P is maximum. So intensity minimum, intensity maximum. This is one more bit. Okay, this is a overall wave pattern overall. Okay, and you can see here for every 1 by f1 difference f2 second, one maximum and one minimum will be formed. Okay, so in the discussion part, I have taken f1 10, f2 6. So we got bit frequency 4, right? That means hearing 4 maxima and 4 minima, right? That is what given here 1 by f1 difference f2 second, one maximum and one minimum, right? And one maximum and one minimum is called one weight. Okay, right. Next, maximum intensity is called waxing. This is the one term using. Maximum intensity is called waxing. Intensity minimum, that is called banning. Okay, right. Now here one more important point while solving problems using frequently, adding wax to prongs. For prongs of tuning fork, if we add wax, then since mass increased, they vibrate with less frequency. So frequency decreases. I am repeating. If we add wax to prongs, weight of prongs increasing means mass of prongs increasing. So they vibrate with less frequency. So frequency decreases. Next, one more term, filing. Filing means rubbing. When we are rubbing prongs, mass of prongs slightly changes, means slightly decreases. So since mass decrease, they vibrate with more frequency. So increases frequency because mass is reduced. Okay, na? Mass is reduced. Okay. Let us see problems to get more clarity. See the question. So this question taken from H.C. Verma. A tuning fork produces 4 beats per second with other tuning fork of frequency 256 Hz. The first one is now loaded with a little wax and beat frequency found to increase to 6 per second. What was the original frequency of the tuning fork? Original means before adding wax. Okay. So you are given two tuning forks. One tuning fork frequency is not known. Other one given 256. And beats are 4. First one is now adding some wax. Then what happened? Beat frequency increased to 6. So we have to find original frequency of tuning fork. See how we start the problem. Right. Tuning fork. Let us say first one frequency F1. Second F2. Second given 256. Okay. H. F1 is not there. In first case, beat frequency given as a 4 means 4H. Right. Now what happened is adding wax to this first one, then frequency will decrease. So first what we are doing is beat frequency 4 means frequency of the first one either 256 plus 4 either 256 plus 4 That means 260. Second possibility, 256 minus 4. 256 minus 4. That is 252. Answer is now one of these two. Okay. Now to decide which one of these two is the correct answer, we are given one more condition. That is, wax is added to first one. When wax is added to first one, its frequency decreases. Okay. Now see carefully. Frequency here 256, right? Frequency 256. This may be 260 or this can be 252. Okay. Now see what happens. For first one wax added, frequency will decrease. This becomes less than 252. This will become less than 260. But condition given that beats are increased to 6. In second case, beat frequency given as 6H. If you take answer is 216, it becomes now frequency less than 260. Then difference will decrease. Difference will decrease. So it is not matching with the given condition. Okay. It is not matching with given condition. If you take 252, now frequency will be less than 252. Then difference becomes more than 4. I am repeating. If this is answer on adding wax, frequency becomes less than 252. Then difference will become more than 4. Means it is matching with the given condition. Right? That means answer must be 252. That is original frequency. Okay. So this is a way we have to solve problem. Means first getting two possibilities, 260 or 252. To verify one of these two, which is correct one, we are given one more condition. Okay. Adding wax, frequency decreased. Means on adding wax, frequency becomes how much? According to given number of bits, it becomes 250. Okay. Now difference equal to how much? 6. Right? This is match. That's why original frequency is 252. If they ask frequency after adding wax, it is 250. Okay. If they ask what is the frequency of first one after adding wax, it is 250H. Right? Okay. Let us see next problem. Okay. A tuning fork of unknown frequency makes 5 beats per second with another tuning fork which can cause a closed organ pipe of length 40 centimeter to vibrate in its fundamental mode. The beat frequency decreases when the first tuning fork slightly loaded with wax. Okay. Find its original frequency. Students, if you observe carefully, difference between the previous question and this question. In previous question, frequency of one tuning fork given directly. But in this problem, frequency of one tuning fork, we have to find. See what you are given. Tuning fork which can cause a closed organ pipe. Length how much? 40. To vibrate in its first harmonic. Fundamental mode means first harmonic. In first harmonic in closed pipe, frequency is how much? V by 4L, right? In closed organ pipe, in first harmonic frequency is V by 4L. V value 320. 4L, 4 into 0.4. 320 by 4 into 0.4. It is a 200, right? That means one frequency given as 200 indirectly. We have to calculate. Now see carefully. Beat frequency decreasing when first tuning fork slightly loaded with wax. Beat frequency slightly, sorry, decreasing. Okay, see how we solve the problem. Given slightly decreasing, right? Okay. First one, F1, which we have to calculate. Second, F2, this frequency equal to V by 4L. Okay, that's the condition given. V value given 320 meter per second. L value given 40 centimeter, that is 0.4 meter. This becomes 200. Okay. So previous question, this question almost same. Only change. In this, we have to find a second frequency from the given condition. Now, given that beats are 5. Beats are 5 means this F1 can be 195, one possibility, or it can be 205. We have two possibilities. Now, one more condition given that wax is added, then beat frequency is decreased. Beat frequency decreased on adding wax, right? That means when this is a 200, if you add wax, in this case, its frequency will be less than 195. Then difference between that and 200 will increase. But condition given, it will decrease. I am repeating. If this is answer, when we add wax, its frequency becomes less than 195. Then difference of that frequency and 200 will be more than 5. But condition given, decreasing. So this is not answer, right? Coming to here, 205. When we add wax, its frequency will be less than 205. Then difference will be less. Therefore, this is answer 205. That is answer before adding wax. Okay, like this we can solve problems. I hope you got clarity.